Okay. All right, we're going to start chapter 12. Chapter 12, we're going to spend more time talking about circles. Um, so we're going to start off today talking about tangent lines. And in this case, the tangent means something a little different than it did when we were talking about triangles. It is the same word and it's spelled the same, but it doesn't refer to the same thing. Yep, not very original here. Couldn't even come up with a new name. But anyway, so we're going to tangent to a circle is a line in a plane of the circle that intersects the circle in exactly one point. So I have a circle here, and this is my circle C. And if I have this line here, this is not a very good drawing because my circle's not very good. So this is my tangent line. So line T is tangent to circle C at point P. So technically that line there only touches the circle at that one point. Point of tangency is the point where a circle and a tangent intersect. So in this particular problem right here in this picture, point P is my point of tangency. All right, so theorem 12.1 says, if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So what this is saying here, so if this is my tangent line right here, I'm going to call it T still, it's saying, so if a line is tangent to the circle, then the line is perpendicular to the radius at that point of tangency. So that's perpendicular right there. Okay? So, and this is my radius right here. So radius is perpendicular to T. Obviously, there are other radii in this picture here. You know, like this one right here would be another one as an example. But this is just talking about the tangent line and the radius together. So you have to find those ones there at that point of tangency. So yeah, there's one that goes right here, but that's not at the point of tangency, okay? So just at that point of tangency, they're perpendicular. So in this one, you could try this one on your own if you wanted, or I'm going to go through it right now. So it says finding angle measures. So it says ML and MN are tangent to circle O. What is the value of X? So if these are tangent right here, then I know that these are 90-degree angles. This is a quadrilateral. If you remember from chapter 6, we have that formula n minus 2 times 180. So if we have 4 sides, minus 2 times 180, that equals 360. So all the angles inside here add up to 360. So I have 117 plus 90 plus another 90 plus x equals 360. So I do the math there, add those up, subtract. You end up with x being equal to 63 when you do all that math there. All right, this one. So this one says, what is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above Earth? Earth's radius is about 4,000 miles. So, I don't like that picture that I drew there. It's a very large circle. And I'm not going to be able to draw my airplane being 2 miles above the Earth. And now my whiteout's being finicky. All right, let me draw a smaller Earth. Okay, here's smaller Earth. I can draw a better circle too if I draw it smaller. All right, so it says here, what's the distance to horizon that the person can see in a clear day? All right, so basically, you have this airplane that's 2 miles above the Earth. So here's the 2 miles, okay? And then it's asking you for what's the distance to the horizon. So it's asking you for this distance right here. So this would be a point of tangency. So then if this is my center right here, this is a radii right there, okay? So here's the airplane's up here, and the airplane's directly 2 miles above Earth. This is the distance to the horizon. This is the radii right here, where this is 4,000. And then if I can remember, this is a 90-degree angle because this is the tangent line, because I drew that line in there, so it's the tangent line, and it's meeting at the radius, so it's perpendicular. And then this right here is more radii, another one, so that's another 4,000. So this whole side right here is 4,002. So if you notice here, what you have essentially is this poorly drawn right triangle here, where you have a D here, you have a hypotenuse that is 4,002, and you have one side here that's 4,000. So when you go to find that D there, you're just saying 4,000 squared plus D squared is equal to 4,002 squared. Do the math for this one. This is approximately 126.5 miles. All right, theorem 12.2 says if a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So here's my radius. So this one's kind of going backwards. So it's saying if we know that this line right here, so it's like the converse, if we know that the tangent, this line is perpendicular to the radius, then T is tangent to the circle. So finding the radius here, so in this one right here, again, you have another situation here where you have like a Pythagorean theorem here, all right? So in this particular one right here, it says, what's the radius of circle O? So X is obviously the radius. This is the 90-degree angle here, so there's 10. The hypotenuse side is X plus 6, and this is X. So when I do this, I'm going to have X squared plus 10 squared equals X plus 6 squared. Now, what you guys generally forget is that this X plus 6, remember, it's like this. So the answer to this is not just X squared plus 36. You're going to have to FOIL this. So I would have the first, so I'd have the X squared, the outer would be 6X, the inner would be 6X. So when I put them together, I get 12X, and the last is 36. Over here, we have X squared plus 100. What'll happen here is these X squared terms will cancel, and I subtract those. And then I'd have I'm going to move the 36 over here. Then I have to divide both sides by 12, so X ends up being 5 1/3. There's no units on this one, so I'm just going to leave it like that. Sometimes you need to identify if something is tangent. So the only way that this line right here would be tangent is if this is a 90-degree angle. And if that's a 90-degree angle, then the Pythagorean theorem should work here. So basically what we're doing here is we're checking for a right triangle here. So I do the 7 squared plus the 24 squared, and I'm checking to see is it equal to the 25 squared. So you do this math here. So you have 625 on this side. 25 squared is 625. So yes, since the Pythagorean theorem works. So I'll say yes because the Pythagorean theorem works. Okay. And the next one says, if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So here we have A, here we have B, and here we have P. So since these segments here, so let's say these are both tangent because they're only intersecting at that one point right there. So these segments right here are congruent because they share that endpoint. So in this one, we've seen these inscribed circles before. So it's a circle O is inscribed in triangle PQR, which has a perimeter of 88 centimeters. What's the length of QY? So this tangent shares the endpoint with this tangent. So if this is 15, then this is also 15. This part shares that endpoint R with this one. So if this is 17, this is also 17. QY, I don't know, but whatever that is, it's the same thing over here. And you know that the perimeter, so all the way around, is 88. So basically I have 2 times 15 because I have two 15s. I have 2 times 17, and then I have 2 times x is equal to 88. So here, so 2 times 15 is 30, and then 2 times 17 is 34, so 64. So then 88 minus that 64 is 24. So x is equal to 12, so then that means that QY is equal to 12 centimeters. Again, these are all centimeters. I don't need that notation there on top of it because I'm referencing length. All right, I'm just going to look at number 26 with you because a lot of the other ones are pretty straightforward. Some of them are the proofs, so those will be a little bit different, but let's just look at number 26. All right, for number 26, there's a interesting little like pulley here. So it says a belt fits snugly around 2 circular pulleys. CE is an auxiliary line from E to BD. CE is parallel to BA. What type of quadrilateral is ABCE? Explain. All right, so right here, you can see that this is a tangent line. It only intersects at one point right there. So because it's a tangent line there, those angles, and these are the radii here, 1 radii, these are perpendicular. And then if these are parallel to each other, but if these are 90-degree angles, these are also 90-degree angles, because if these lines are parallel, the same side interior angles have to be supplementary. So I end up with a rectangle. I have a rectangle because I have 4 right angles and I have 2 parallel lines. Then it asks me for what is the length of CE. Now when you're doing this problem here, what you kind of want to think about is how can I make that right triangle? So right now, here's the E and the C. Remember, these are 90-degree angles up here. So in this particular one, what we want to do here, we know that this distance is 35. Actually, this part's the easy part, sorry. This one's 35. It's because it's a rectangle. So if it's a rectangle, this side, A, B, and C, E are the same. Sorry, I was thinking about the next one. All right, and I drew this picture wrong. So that's why I'm getting all confused here. All right, the next one. What's the distance between the center of the pulley? So now we want to try to find the right angle. So here's D, here's E. All right, and then we know that C is somewhere like here or something, right? So DE, this right here is not the right angle, but wherever that C was, remember that point C there? So that point C there, this distance, the CE was 35. This was the right angle. So this would be the hypotenuse right here. This side right here, so what I'm looking at here is just this distance right here. This side of the, remember this shape right here is a rectangle. If this is 8, then this is also 8. Rectangles have to be the same on both sides. So if this whole thing is 14, 14 minus 8, that would make this little piece 6. So this little piece is 6. So then here I can just use the Pythagorean theorem. So 35 squared plus 6 squared is going to be equal to DE squared. So when you do that math there and solve for DE, DE ends up being 35.5 inches. Okay. And that's it for 12.1.